All right, I want to start talking about procedural terrain in a different set of eyes, a different hat. I want to take off our coding hat and start thinking about this from design elements. Now, first of all, I want to show a feature that we're going to be developing in this one right away so you can see it. So, terrain features as elements that can just be dragged and dropped like houses. So I can just drag this bay over to here, and now I've got a bay on this side. That is not how you operate and edit terrain in our current setups. Now, this doesn't need to just be this. We could also make it a lake, a smaller inland lake. We can also raise up the height of it. So I'll just put it 102, and we just happen to have it over here, and where it connects to a couple other spots. Whatever. The point is that we can make terrain elements that can then move around the terrain, and everything, once we move it off, goes back to the way it was. So let's start diving into the code for how that happens. But of course, the design choices are going to be key here. Before we dive into the code, let me explain one more thing about this. Imagine for a second that we need to guarantee that when a player comes into the game, there will be enough surface area around them that they can start to build their level, their base there. This is StarCraft, for instance. They need a space to build their base with resources. Okay, well, we happen to know where one is. We put one here. Here's the spot to drop the player, right in the middle. That's easy. It's done. So I want to express some things, and I'll show a couple reasons of how that can break down for artistic choices and where we need to think about things. And there will be solutions later in the series for most any of the problems that I introduce here. Okay, so how does this code work? Because first off, moving objects around Unity like this, or the terrain pieces, that's not how the system works. So this is purely our own code, and it's actually pretty small. So let's go ahead and dive into this. Let me change this to like 50. That'll make a bigger impact later. There. Okay, so let's dive into the code. Terrain flattener is the new item that we've added, and this is the whole script right here. This is it. Well, there's the using statements, and I don't even need that one. Okay, so there is no autoplay. It's not. What was the term? Have it over in terrain tools. It's not execute always, so it's not always executing. And it also doesn't have on validate, but yet every time that I make a modification to it, the scene updates and it gets all this processed in there. So we'll have to talk about how that happens and why, and potential issues that might create. Safety checks we'll have to put in place so that we don't destroy our performance. All right. But for right now, refresh content, that's effectively drawing that circle. It takes a circle at a radius we decide from that position and says, make all the height around this for one radius, one circle out to match this height. That's all this code does. It's pretty straightforward and simple. It's lightweight. You can see there's not a lot that it does. But there are some changes to my code and also to terrain tools, so I want to go over those as well. High level, this command takes our position, the position of this object that we're dragging around, that bay or that circle of land, and it takes just its Y position. And then it figures out, okay, our terrain height is from 0 to 600, and this is at 300. So I'm going to give back a decimal of 0.5 because the terrain has to be between 0 and 1. And if it's at 800, when our terrain maxes out at 600, then it's going to give back a 1. It just peaks off at 1. Its bottom number is 0. And otherwise, it's a percentage of where it is in between. Okay, so that is how we are getting the height. And what our height is for. So when we are setting the terrain height, that anything within a certain distance, we are setting it to that height so it will match the object. Okay, now how do we get the distance? Well, we check the distance between the transform position, the object we're holding onto, and the world position for the height map index. So we've got X and Y, and we're effectively going through our height map mesh to set variables and check their position. We did this code before where we converted where we were in the height map, looking through the 2D array, and figured out where each one of those points came out in real world space. All I did was wrap that in a function, so anything else can call it for this terrain object. And so I pass in the X and Y, and that just gives me the real world position. Now, I'm not doing it through vector3.distance. And that I am, but I have another layer on top of there. I'm going through something called zero distance. Maybe Unity has some term for this that I'm just not familiar with. And there's already functionality. If anybody knows about it, please, by all means, share it. I'd love to learn it. And some of the other related things that it most likely carries. Okay, so zero distance is effectively doing a vector3 distance against those two variables that get passed in, but it sets both of their y values to 0. That means that if we have mountains over the land, we have all these various mountains and hills, yay, mountains, that as I move one of them, it's actually, I can't actually demonstrate with that. So zero distance, oh yeah. So if I'm counting the distance from here to here as 1, then the distance from here to here would be half of that if we're pushing it all the way down in here, back to the same height as the other two. That's effectively what this is doing. It's counting it down inside it. Because if we didn't, what's going to happen is some of the elements are going to be farther away than we intend them to be. And so it'll look weird. In fact, let me show you. Control KC. Control KC is control code comment. And then KU is uncomment. All right, so now check this out. We have that circle there, but that's going to go away. It'll be something else in a moment. Once all code updates, recompiles, runs, does something. 17 seconds, what are you doing? Unity. Where's my code? Oh, why do I have a debug point? Stop that. Okay, back into here. Look at our terrain. That circle, it just disappeared. It's gone. We don't have that circle anymore. If I move this around, you can kind of see it emerge, but it goes away. So what happens if this were right here? This is where we had it. I press F and let's zoom in. Well, our spot where a character is starting out is going to be right here, over a pit that they suddenly just fall into. Because, I mean, we designed a place that's supposed to create a spot where they can start generating what they need for their world, but then it drops them over a pit. That center, we've already got a point for it. Let's drop them right there, over a pit. That doesn't work. While that might create some interesting design choices, like when this goes out a little farther, you don't notice it as much, but that's just because of where it is on the map. If I move this over to one of these areas, same thing again. It might not be, it might still provide what initially looks like plenty of space, and so it looks like it'll work, but you have to test your design elements over different parts of the system. So this one, not going to work. That could drop you into an area that you don't want. We effectively want to make sure that when we have this, Control KU, that it's going to give us that full circle of space. That's what we really needed to do here. Okay, so we have our full circle of space, and it doesn't matter what height it's over. If I drag this all the way up here, it should still work. All right. So there is one other thing I want to show in the code here. So when we're looking at this, we get our height from taking a world position and converting that into a terrain height. How do we do that? That's kind of important. So let's take a look at terrain tool. And oh wait, it'll be faster if I just go to here and then hit F12. Okay, this code, it does more than it needs to, depending on how you use your game. So I'm going to set this to 0. I'm going to simplify this down. Get rid of this. Don't need that. I can get rid of that whole line right there. Great. So this works. I'm going to save it and go back into the game and then move this around. It works. It goes up and down. Great. It works. However, let me show you something else. Let's assume that our terrain height is not at 0, but at -100. Where is it? It moved. Oh, wait, there was a little white speck right there. That is the flattener cube. Oh, that wasn't even the right spot. That was just another piece of terrain poking up over the surface. But we've got our flattener cube, which is like way over here. That's not where I expected it, but whatever. Flattener, yeah, that's correct. Okay, so if I raise that, if I bring that up, it will eventually bring the circle with it, which it is not doing. Why is it not doing anything here? What did I break in the code? Ooh, I'm not really sure. Oh, I duplicated stuff. Stop that. There we go. Control D. I really wish that Unity would not use Control D to duplicate. Like, I like the feature, but if you're holding it down for more than half a second, I wish it would just come to the conclusion that you're trying to move around in the scene and not try to duplicate a whole bunch of objects. And if it already did, then unduplicate them. I've ended up having a scene get horribly slow and choppy because it suddenly had, I think, around 80 or to 100 terrain instances in there, all trying to render and overlap each other. That was horrible. Okay, so we have this object here, and it's definitely off position. So let's, if this terrain doesn't match, that is exactly 100 meters off. So if I actually take that child cube object and I say that is going to be -100, it matches perfectly. Let's go into here and press F. See, it cuts off right in half. That is because the terrain is 100 meters down, so our object is 100 meters down. Our design tool doesn't line up anymore, and that would make it a bad experience here. Let's go into this, and I need flattener, F to focus. Hey, what's going on? Thank you. You unable to focus? There we go. So that is our flattener. So if I take that terrain and I move it back, let me get a better vantage point from here. If I go back to the terrain and I reset this to 0, it'll work. It comes right up to where it was supposed to. Let's put that back, -100. And now let's go fix the code. So inside of here, I'm going to Control Z this. And the first part of this, it was just returning 0 if we were under 0. So great, that worked. Now we're going to return 0 if the Y position is less than the lowest position supported by the terrain, which is terrain transform position Y. And then we're going to take that same point, and if we're greater than that plus the size, which is terrain.terrain.data.size.y for height, then we're going to return 1, the maximum value that can come out of here, because it's always going to be between 0 and 1. And then we want to divide this. But let's say that we're at -100 and our point is -50. We're going to have -50 divided by 600. That doesn't work. We need to increase the y outside of that range. And basically it means if we're at -100 for our terrain starting point, we need to add 100 to the y that came in, so we can figure out how to make the equation work. So all I'm doing here is I'm saying y plus equals 0 minus terrain.transform.position.y. That maybe not necessarily clear. We're effectively saying that it's going to be 0 minus -100, which since it's 2 minuses right there, that flips, and we end up with +100. So we're taking y and we're adding 100 to it. Okay, so now that brings our y value, if we were at -50, now we're at +50, because we have gone exactly 100 up from where we were. Now that we have that, we run this code and it will work. I'm going to save this and return to our program. Return to our regularly scheduled program. All right, there it is. So if I have the flattener, you can see it's right up at the top and it follows perfectly with it. That's what we wanted. Okay, so this is effectively working, but the biggest thing that I want you to start thinking about inside of your procedural code is to stop thinking about it as what can you do to make it look interesting, and instead, not even just what can you do to make it functional. Of course, that is important as well, but it's how can you satisfy design requirements? And so your design requirements from what you might traditionally see have to change. You might traditionally see something saying, in the maps, we have to make sure there is sufficient space for a base to be built, and that we have points for that to show up. Or we might not even say that. We might just say we need spaces. We need the capabilities to have open areas of maps, to have closed area of maps, so designers can come in and manipulate this to make what they need. It might be vague like that as to showing what they need or what to develop. And you need more specific stuff, like there need to be between 4 and 8 potential locations for a base to show up or be generated. And we have to have starting points for each one of them. Then there have to be pathways within the maps for players to be able to get to any other part of it so that they can attack each other and engage in battle. And then there can also be additional offshoots of where these things are going. So what you're kind of looking at is what are the design elements and choices that the designers use when creating these maps. And you need to really work that out. You need to figure that out into ways that you can program. So that means, in a lot of cases, simplifying down what is being requested into something that you can code. Because a lot of times it's artistic in nature, and that's creative, and it's hard to write specific code elements for. Okay, so that's effectively all this stuff is. If you have ideas that you want to see me bring out in this, I'm planning on diving next into force graphs. Force graphs so I can create multiple sets of these on the same terrain, and then also put connection paths to make sure that I can get from point A to point B. So we'll be diving into those areas next. If you have other areas that you want to see it dive into for how we start putting in design-based procedural terrain, then please do. Please bring up any kinds of ideas, thoughts, questions, and I'd love to answer them and respond to them in some of the future videos, or just respond or reply directly in line. All right, thanks. I'll talk to you later.